Okay. Again, just you got the scenario. What is the role of the resource allocation graph? Resource allocation graph is being used to represent a whole system, and by seeing at that system, by seeing at that diagram, we can analyze whether there could be a deadlock. So here, processes are represented as a circle, and the resources are represented as a square, what we call rectangle. And in this one, you put it as a dot. And what that dot indicates? The dot indicates the number of the resources. One process can be there. Processes could be individual one, but the resources can have the multiple identical resources, like the USB. So laptop can have the multiple USB, and all are with the equal power. Then there are edges. Set of the edges. The assignment edge. The assignment edge, it is the edge representative or going from resource to the process. What it says the instance RJ, the resource RJ, it is been allocated to the process PM. Now you can see usually we allocate a resource, and this is what a request edge. What is the request edge? The process P is demanding the one of the resources of the RJ. Now can you see the difference between the two edges, request edge and the assignment edge? What is the difference? What is the difference?
Starting and destination.
Yeah, ending points. Here, request edge, it is ending at the boundary. What does it mean? I want any of the resources. Now let's say there are 40 resources and I am demanding, I want the bench, this particular bench. So I have simply said I want this bench because I know all these 120 benches are of the equal capacity. That's why process is demanding only one of the resources. Operating system will see out of 3 which one is available. Whatever it has its own theorem, it will pick up one of the instance, and that instance will be allocated to the process PM. So that request edge will now convert it into the assignment edge. And that's why you can see assignment edge is not starting at the boundary, rather it is specifying that second number of the resources it is being allotted to the process. Now by that phenomena, just let me know P1 requesting one of the instance of the R2, P1 got to one instances of the R4, P2 to there. What about P2? Allocation, what the P2 has allocation? R1 and R3, and it is waiting for
R4.
What about P3?
Waiting for R3.
No allocation, waiting for R. Okay. Now does it have the deadlock?
Yes,
Does it have a deadlock site?
yes.
How? Okay. Now again this one. Does it have a deadlock? Akash, होता है deadlock? How this will happen a deadlock? P1 get the instances, no? See, there is a cycle. There could be a deadlock. But how P1 has one instance and 2 instances are available. P1 can get this instance, it will release this one. I don't think it will have a deadlock. So it's a necessary condition but not a sufficient condition. Now in this case, does it have a deadlock? How? 2 instances of the R1. Now tell me, does it have a deadlock? How many cycles are there? 2 cycles are there. How many max instances are there? 2. So 2 instances, 2 deadlock means, 2 cycle means there could be a deadlock could be one only. 2 instances, 2 cycle. 1 instance, 1 cycle. Deadlock. 1 instance, 5 instances, 1 cycle. No chances of deadlock. Likewise. So here if you see a cycle, even if you see the cycle, there may not. Okay, now tell me in this case, is it a deadlock? Yes or no? How? cycles are there by which we can't release the resources, so there is a deadlock situation. Now in this one, we can see a cycle over here. Is it a deadlock? Yes or no? Cycle? Yes. Deadlock? Cycle sufficient condition match. Necessity things matching. PB can release its resource. PB doesn't want anything else. PD will also release the resource. So I don't, maybe I can, no deadlock. You have any confusion? So there is a cycle but no deadlock because of the multiple instances the deadlock may not be there. Okay, so what we have learned as of now, so deadlock, it is obviously the worst situation. So being an operating system, we should have the coordination between the number of resources and the number of processes, and if that matching won't happen, there is a deadlock occur. So to realize whether the deadlock would occur or not, scientists do the representation of the operating system as a graph, and by analyzing the graph they define whether the deadlock would be there or not. Now how we can handle a deadlock? Basically operating system actually ignore the deadlock. Why? Because handling a deadlock, it is given a freedom to the developer itself. It is given a freedom to the developer itself. They, at their level, they are doing the handling of the develop. So you people are experiencing, you people are doing a, let's say in the Java programming. You people are doing a Java programming or C programming. Java you done? Or you are doing C, let's say C, Python, Java, whatever, any programming language. You are doing that file writing code. So in a different mode we could open a file. That W mode, R mode. If it is a R mode, what does it mean? Any processes can use that one. If it is a W mode, what does it mean? Write mode. Only one process can do that one. If you are learning the Java, you just have the experiment. Just run the two Java programs simultaneously and the same file try to open into the write mode. Would you open to write the same file into the, once that one particular Java file is opening the one file into the writing mode, let's say a.txt, and you run again another Java program, in that program you are opening a.txt into the writing mode. Java program won't allow it. So what I want to say, you just have experiment, even if you are done with the C also, maybe, I don't know. You are done that file writing into the C, or you can have that experiment. What does it mean? Operating system given that freedom to the developer. So Java programming API or C API had designed such that they maintain those things, mutual exclusion. Okay? So we won't ever experience by the operating system that it is handling a deadlock, it occurs a deadlock. I am not saying that system hang is not a deadlock. System hang is not deadlock. It is a mouse movement that delay it is been there. Maybe your system latency, what we call. It's not a deadlock. When your system hangs, it doesn't mean a deadlock. Operating system has given a freedom to the developer. Your Java developer, your whatever developer it is been there, they have taken care of that deadlock not to occur. So first thing, how we can handle a deadlock? Obvious prevention is better than cure. We have to see deadlock should not occur. We should have such arrangement that deadlock never occur. Even if the deadlock would occur, how we could avoid it? What is the prevention? I will not allow any request of if any process says I want a 50 benches, I will not allow the process to enter into my system. Deadlock prevention. What is deadlock avoidance? Even if that process tries to enter, how I can avoid it? How I can bypass that particular process? Even if the deadlock would trying to occur, how I can avoid that? First case, not to occur. But still it could occur, how I can take care of not to occur. If the occur, we should detect it, why it is occurring. And if it is detected, take a medicine, kill that process, take some prevention measure. So these are the four handlings. One, as I said, operating system usually ignore the deadlock. it pretend like deadlock won't occur into the system. It has given a freedom to the OS itself, developer itself. So deadlock prevention, what is the first thing? We should have a deadlock prevention. You can have your water like refreshment, okay? What is a deadlock prevention? As I said, prevention is better than cure. What are the 4 conditions to deadlock occur? Mutual exclusion, hold and wait, no preemption, cycle. There should not be a cycle, sequential. Okay. So those are all 4 conditions has to be there. If any of the condition would off, what will happen? Deadlock won't be there. So what is my case? What is my role being a developer? I will allow to not to occur a deadlock. Any of the 4 conditions I should make it off. What is the one thing? Mutual exclusion. Even if you are saying that the out of 4 condition, one condition, if I make one condition off, we can make the deadlock not to occur. But very first thing is that we can't deny the mutual exclusion. So even if you are saying, what I am repeating, even if you are saying 4 condition, out of the 4 condition, one condition to be off, mutual exclusion never be off. What does it mean? 2 processes never access the same resources at a time. Even if we are saying to avoid a deadlock, we should not allow the mutual exclusion, but we have to allow the mutual exclusion. If someone is saying we are running out of the time, 2 teachers can't be into the same classroom. Mutual exclusion not allowed. Mutual exclusion can't be denied. So out of 4, how many left with us? 3. So mutual exclusion is compulsory. It is always true. Now only we have 3 options. Out of 3 options, any of option we can make it false. Have you got situation? Though there are 4 conditions, one condition we have to make it false, but mutual exclusion we can't make a false. It has to be a there. So it has to be a true always. So mutual exclusion got some exemption. It's out of no game. Not only 3 things are there. Which are those 3 things? Hold and wait, circular wait, no preemption. Okay, because if the resources are the non-shareable, we can't allow the 2 non-shareable means, can you give an example? Printer, we can't print PPT and the PDF at the same time. Again, any non-shareable, your file, A.java, B.java, both can't work into the write mode into the A.txt. Write mode मध्ये दोन्ही files open नाही होऊ शकत, non-shareable. What is the shareable resource? Can you give an example? This one, PPT, 120 guys are, or 60 guys are reading this one. It's a shareable or a non-shareable? Non-shareable. Shareable. We use the that news bulletin, some web pages. It's a shareable or a non-shareable? Shareable. Okay. So mutual exclusion, non-shareable resources can't be get shared, so we can't make it off. We can't make it false. It has to be a true. Hold and wait. What is the hold and wait policy? Resource holding one and waiting for other. We have to ban it. We have to ban it. How? Just think reverse. How we can ban it? Recall that our previous example. Process A is holding this one, waiting for this one. We have to ban it. How we could ban it? How we could ban hold and wait resource? Allocating timer, okay. We should ban hold and wait. We can't ban mutual exclusion. So we have dismissed that idea. Now we have to focus on other 3. How we can ban hold and wait? How we can avoid hold and wait? Be fast, quick. Can we ban hold and wait? We should not allow hold and wait. How? Just think of it. Okay, what is a hold and wait? How we can work? So if the process is holding the resources and if it has demanded some resource, operating system sees it chart, okay, you are a process A, you are holding the printer and you are demanding the CD-ROM. I am banning the hold and wait. So what does it mean? I will not allow the request. So in our case, process A is holding the CD-ROM. Now it can't wait for the printer. Likewise, we are denying to that one. We should not allow the hold and wait. Are you getting? Otherwise, if process say that I want both the resources. So what the operating system says, before entering, before starting, only demand both the resources. Maybe you can use the other resources later on. But once you start execution, you can't demand for the other resource. Once holding, एकदा तुला होल्ड करायचं किती 2 घे 4 घे 100 घे, no issue. So process A has created, it is been entered, so it can demand the 2 resources. Currently I am using a CD-ROM, but maybe into the future I may use a printer. Now if the process B will come and it will say, I want printer. Now what the operating system will say? Printer is held by the process A. Even if it is not been using, it is been held by the process A, so you can't demand the printer. So obvious deadlock won't be there. But again, what is the drawback of that one? That it may causes the low resource utilization. How low resource utilization? Because we are banning the hold and wait, we are saying the process A just demand into the future in advance how many resources are required. Process A is using a CD-ROM, it may not using a printer. So is it a low resource utilization? Because printer is simply allotted to the process A, but it is not being used. Are you getting? And it may again causes the starvation. What is the starvation? Who is into the starvation now? A or B? Sorry? The one who is waiting. Who is waiting there? B. What is starvation? Unlimited waiting. What is starvation? Process wait indefinite time. Process B is waiting for the resource get. So hold and wait, by this way we can avoid the deadlock, but again it has a side, have what again, a coin has a 2 sides. So that is what the another side. No preemption. What is the no preemption? What is the preemption? We should ban no preemption policy. What does it mean? We should allow the preemption policy. What is the preemption means? Revoke the resources. Okay, now let's say this is what a process, this is what the one process, it is demanding the resources which is being held by this resource. Okay, this one process, it is demanding the resources which is being held by this one resource. And this is what again a process which is holding one resource and waiting for the resources that is being used by the other. So what is the no preemption policy we can implement over here? It is the no preemption policy we can implement over here. There are 2 ways by which we can have the no preemption case. There are 2 ways by which we can have the no preemption case. So here, this process is waiting for this one, and this particular process is again waiting for this one. So what is the no preemption policy? How we can banning it? Because this particular process again it is waiting for this one, just take out the resources, the middle process, and then allocate to this one. So instead of sending one process and another process into waiting situation, he is waiting for him, he is waiting for him. Okay, better take out the resources from the middle process, let that process complete its execution, let that process will complete its execution. Once both will complete the execution, the middle process will complete the execution. This is how we can implement the preemption policy. Banning the no preemption is implementing the preemption. Preempt and preempting the resources from the middle one. Why? Because of this one, these 2 are waiting. Are you getting? One situation. Now again, another way, another protocol. If this particular process is waiting for this one, if this particular process is waiting for this one, in previous case I preempted the resources because he is waiting for another. Now in case he is executing, he doesn't have any other demand, so in that case I won't disturb this one because he is a good process, he is a will come back to this process. Now I'll see you are demanding this one. If you are demanding this one, just release the resources which you are holding, because right now you can't complete the process. Have you got the difference? The two versions of the preemption one. Have you got the difference? What are the two difference? If this is what a process they are executing, we have to see its dependence. Dependent, take out middle one. If dependent this one, he is not dependent on another, take out this. That is what the two protocol. Just read in fast, you will get to know what we have discussed. If you can see slides back, can you read? Please read protocol 1.
Process is holding some resources and
Be loud, I can't hear.
if a process is holding some resources and requests another resources
Hmm.
that cannot be immediately allocated to it, then all resources currently being held are preempted.
Okay, so what is the protocol 1? आपल्या केस मधला हा प्रोटोकॉल इथून मी रिवोक केले का इथून रिवोक करणे, which one is the protocol 1? I have taken, we have discussed two scenarios, na? Revoking from this person, what's your name? Shashank, what's your name?
Prajwal.
Prajwal. Revoking the resources from the Prajwal or revoking the resources from the Shashank is the protocol 1. प्रज्वल, तुमचा फ्रेंड नेम नाव घेऊ नका. I read the protocol 2 now. You are in. Navedika will. If the requested resources are not available, check. If the requested by the Prajwal is not available, check whether they are allotted to another process waiting for additional resources. So it is being held by the Shashank, who is waiting for the additional resources that is being held by Aniket. So in that case, to whom we are suppressing? Prashant, this one, Prajwal or Shashank? We are taking up resources from the middle person. That's the protocol. What is the first one? He is executing its task. So we are only making between this particular person. I got no preemption. No preemption banning means allowing the preemption. Avoid the circular wait. What is the circular wait? A is waiting for B, B is waiting for C, C is waiting for A. Ban it. How we can ban it? How we can ban it? How we can ban it? So how we can ban it? Let's say process P1 has demanded R1, process P2 has demanded R2. Okay? Likewise. Now, if the process, let's say R3, we'll take it for making circle. Process, let's say there is only three processes: P1, P2, and P3. P1, it is holding R1, waiting for R2, and R2 it is been allotted to process P2. Process P2 has R2 waiting for R3. R3 it is been allotted to process P3. Now we have to do allocation of the process such that P3 can't go back to the R1. So what is how we can break circulation? If I am holding the third number resource, I can't demand for the one number of resource. Likewise, this is how we can break the sequential one. If the resource R1 it is being held by the process P1, so it can demand R2 and R3 both, because 2 and 3 are successive after 1. Process P2 is holding R2, but it can't demand the R1. It can't go back. So it can only demand R3. Process R3, process P3 is holding R3. So does it allow to demand R1 and R2? No. So obviously that circle won't go back. This is how we can break the circular wave. Process will demand the resources which is next to that one. Maybe into some device table. Every devices will have IO will have the device table. So whatever sequence it is being meant, then process will demand in that sequence only. If I am holding something, I may demand the next resource only. Can't go back to this. Have you got scenario? Now, even if by taking the this keep quiet, even if by taking all those care, if the deadlock trying to occur, how we can avoid that one? So process has to declare, this operating system will declare the available resources, then allocated resources, which particular process has got the how many number of resources, that is auto allocation, and then it future and the request demand. Keep quiet please. So to avoid the deadlock, we assure that system to be into the safe state. Now what is the safe state and the unsafe state, we will see. Instead of discussing this, we will go with the example. Now read the example. Operating system, it has been there. There are three processes, P0, P1, P2, and let's say there are only one resource, printer असेल किंवा USB drive which has a 12 instances. Now process P0 demands 10 instances of the R1. Can I accept the request? Yes. Why? 10 is less than 12. Process P1 demands 4 resources. Can I accept? Yes, because 4 is again less than 12. Process P2 demands 9. Can I accept? Operating system. Process P4 will come, it demands 15 resource instances. Can I accept? So it will not be created. Sometimes you see the situation where the processes are not created. Have you ever seen processor? You are trying to create a file, it will not be created. You are trying to open some file, it will not be opened. What do you mean by this one? Why that will be, that is not been created process itself? Because operating system lagging some resources to create that one. Maybe your memory is not that much available. Like it could be anything. So if this particular process P4 is demanding 15, I can't allow. Why? Its demand is more. Now I have 12 instances and they have demand like this. I have to distribute according to that. So my distribution should be such that there will not be any worse situation. So I will allocate 5, 2 and 2. I will allocate 5, 2 and 2. This one is a pen, no? This one? This one? Okay. How many are allotted? 5 is been allotted to P0, P1 got a 2 and P2 got 2. So how many total are allotted? 9. How many left? I guess subtraction is okay for you. 3. Okay. Now how many left? More. How much more want? P0 how many wants? To complete its execution? 5. Fine? I had that pen, no? I forgot. This one we have to use? This one is rubber. Okay. Now I have 3 processes running. All are into the now waiting state. Device queue, IQ. Device queue, IO queue, device queue, CPU queue. You know that one? Queues. Now this is what the available one. Which one will get complete its execution first? Whether P0 can complete? I have left 3 resources. P0 wants 5 more resources. P1 wants 2 more resources. P2 wants 7 more resources. So which particular process can complete its execution? P1. So P1 will get complete its execution because I will allocate, keep quiet please, 2 and I got only 1 resource. How the process P1 will have the resource now? 2 are already there. 2 more will be there. How many? 4. Okay. Once the P1 will complete the execution, now P1 will move from waiting state to the running state because the required resources are available. Okay, P1 will complete its execution, request resource, utilize the resource, then release. Once the P1 will complete its execution, what is the role of P1? Release the resources. So 4 resources will be free. So how many resources now into the pool? 5. Now 2 more resource process will yet to get completed. What are those? P0 and the P1. Which one can complete? It requires the 5 and it requires the P0. Now next one will complete the execution P0. I will allocate P0. So there will be a 10. P1 will complete its execution, get terminate, will release the resource. How many resources need into the pool? How many resources will be into the pool? 10. Now P2 can complete the execution. How? It requires only 7 resources, 7 are less than 10. So I will allocate out of 10, 7 resources to P1. Here are 9. P1 will complete its execution, release the resources. All 3 processes has completed this one and they have released the resources. Now in my pool, 3 plus 9, 12 resources are there. So what is this one? P1, P0, P1, P2. P1, P0, P2, this is called as a set sequence. If your existing system will have at least one subsequence, you call it as a system into the set state. Have you got? What is the set state? So set state means there would be a deadlock or not? Yes or no?
No.
No. Had it been possible, even if the demand are into the range, my first allocation is a very good. Because of that, system got it into the situation. How? मिटेगा?
नाही नाही बरोबर
So system into the subsystem. Now do the same thing with the this one. Now again same need, but I change my allocation. For P2 I given a 3. How many left? How many left? 5 plus 2, 7. 7 plus 3, 10. How many left? 2. Now let me know what is the step sequence or how many processes. So I have 3 processes, so all 3 processes have to get executed. P1 can complete? Yes or no? Last row. P1 can complete its execution? I'm asking you, Specs. Yes. Yes or no? P1 can complete the P0 can complete the execution? P1 can complete the execution? P2? No? Okay. What is the sequence? You got a set sequence? How many of you say P1 can complete the execution? Raise your hands. P1 can complete the execution. Raise your hands. Okay, everyone is saying. How many of you say P0 can complete its execution? No one. Next one is P2. How many of you say P2 can complete the execution? Okay, you are saying. So, can you see what is the previous situation and the current situation? Number of resources have changed? No. Well, as it is. Demand change? No. Earlier also 1049, now also 1049. What is changed? My current allocation. And because of that, we can't complete the execution. And it is into the unsafe state. When the system is into the unsafe state, this is called as a deadlock situation. So being an operating system, being the head of the family, I should say how I can allocate a memory, how I can allocate a resources to the, like in our family, how people allocate a property. No one it is being given to a single child. It is divided equally, whatever they have policy. Okay, so while selection we have to do, then only we can avoid the deadlock. And that unsafe state situation is causing a deadlock. So have you got this diagram? Have you got what is the safe state? If there is at least one safe sequence. Safe sequence means a sequence in which processes complete the execution. I am not saying in the sequences in which processes enter into the system. Maybe P0, P1, P2. They are entered in this particular sequence. But I have one execution sequence that P1, P0, P2. At least one. There could be a multiple. But at least one sequence is there. We can say there won't be a deadlock. So I have to avoid a deadlock. What we have to do? We should allocate allocation very properly. Have you got how we can avoid the deadlock? Then, to avoid a deadlock, we will have another version of the resource allocation graph. What is the resource allocation graph? There was earlier only two types of the edges. What are those edges? Assignment edge and the request edge. Okay. One more edge they have added to represent the system. It's the claim edge. What is the claim edge? If I am going to demand into the future, I am holding the printer, and in the future I am demanding the resource CD drive. Firstly, it will be the claim edge. Now, operating system will analyze whether that claim could be acceptable. Okay, now it has been acceptable. Operating system allowed to request it. Now, that claim edge would get converted into the request edge. Now, if the resources would be available, the request edge would be get converted into the allotment edge or the assignment edge. Now, okay, process A, B, printer and the resources. Previous situation. Now, process A is executing, getting R1, demanded claim R2. Okay, now claim has been converted into the request. Now, process B is executing, it is holding R2 and it is claimed for the R1. Now, again I will put a claim edge, not directly request edge. So I will see because of the request of the resource process P2, what will happen? There could be a deadlock into the system. There would be a deadlock into the system. So I won't allow the claim age to be converted into the request stage. Don't do the claim. So I will not allow to even a request also. Why? Because there could be a cycle into the system and there could be a deadlock. So what does it mean? The resource allocation graph will have a newer version or the slight change version. Before allowing to request, people will analyze what will be the impact of the request itself. Have you got? That is by using a claim age. That is by using a claim age. So you can see process A is there, process B is there, process A is holding R2, process B is holding, waiting R2. Now there is a resource R1. Now at the same time, process A and B requested for the R1. Operating system not allowed to request. First it will analyze, they will put it into the site claim age. They will, the operating system put it into the claim age. Now here it is said that there will not be a deadlock, so one request could be accepted. Okay, now let's say B had got the first request, so this claim age is converted into the request age and the request age get converted into the assignment age. Isn't it? Now let's say, okay, in this case claim age will okay. Now let's say A, B are resources, A is holding R2, B is holding R1. Okay, B is waiting for R2. Now A is requested the R1. Now I can't simply allow to request the R1. What I will do? I will put that claim age. Before accepting the request, I will put that claim age. I will see A can't allow the R1. Request the R1. Why? There could be a deadlock. So this claim age will see whether the request could be accepted or not. Are you getting? A slight change. Before converting the request age, we are doing it as a claim age. Now next one, avoid a resource allocation. We have a banker's algorithm. How many of you go to the bank? Ever visited the bank? Yes. In a bank we have one facility to take out the loan. Let's say bank will have the 10 customers as of now. And will have the 1 crore. 1 crore into the balance with the bank as asset. And this person has demanded the 1 crore. Whether bank will allocate all the 1 crore to him? Why? There are 9 other customers. They may demand for the money. So my 1 crore I have to distribute among those 10 customers. Obviously based on their demands, but I should have the wise allocation. So banker's algorithm, it works on the same principle. Even if I have the 10 resources, 12 resources, I can't allocate the 12 resources to the single process. I should have the wise allocation. Are you getting? Why? To avoid the deadlock. Now, let's say n are the number of processes and m are the number of the resources. To have that one allocation, just previous example only. It's similar to the previous example only. So available, banker's algorithm works on, it uses the 4 variables or 4 data structures. Available, it's a length of the m. Available, so what it indicates? Number of resources available. How many number of resources are available? How many number of resources are available? Out of 12, we allotted 10. How many left? 2. So available will be a 2. So that 2 will define available. Max, it defines n process will, how many resources of the n. Process P0 is holding 2 resources of the n. Allocation, whatever max, whatever their demand, out of that how many we have allotted. and need allocation. Whatever max it is been there, how many out of that we are allocating, and need max minus allocation. It is okay. Can you read the flow? How the Banker's algorithm works? Just recall the previous example, then you will get to know. We are just about to cover, just 10-15 minutes. Work is equal to available. You written the previous example. P0, P1, P2, 10, 4, 9, and here 5 to 2. So available is equal. So we are declared the two variables, work and the finish. Work is equal to available. So work is equal to, in our case, how to erase this one? This one?
Yes.
Take out the previous example. P0, P1, P2, 10, 4. बरोबर है ना? And allocation? 5 to 2. First scenario. 5 to 2. Okay. Then 4, 9. Allocation? 5 to 2. How many left? Available? 3. So need matrix means max minus allocation. How many left? 5, 7. Work and finish. Two variables we are declared. Fine. What is the next? Work is equal to available. What does it mean, work now? Work is equal to available. Okay. Finish I is equal to false. What does it mean? P0, P1, P2. याचा finish status काय आहे? False. Okay. Now we have to see all the such a process. You know the flowchart concept, no? We are learning, I guess, 5th or 6th standard in our area. I don't know either what about you, I don't know. Okay, please, we have to finish now. We'll go one by one. Finish I is equal to false. First we'll see with the P0. P0 false, yes. Its need is less than work. What is its needs? 5. 5 is less than 3? No. So we have to come back over this. Finish I. Now I equal to 0 to 1. Finish I is false? Yes. Its need is less than work? You need 2. 2 is less than 3? Yes. What we will do? We will allocate the resource. again, restart. I am pressing something.
क्रॅश क्रॅश झालेलं
Okay. So finish is less than finish of P1 is less than finish of P1 is false and its need is less than available. So what we'll do, we'll allocate the resources to P1. Work is equal to work plus available. Now process P1 will release the resources. Now available resources will be a more. Now how many resources will be there into pool? Don't look at the board. How many resources would be there into the work? Earlier there were 3. We allocated to process P1. Process P1 will complete the execution. We'll mark it as its status is equal to true to or false to true. Okay, now how many resources will be there into the pool? 5. We'll go back to the again next process, P2. What is the need of the process P2? 7. Process P2 has a status false or true? False. First condition is okay. What is the next condition? Whether we can make a need, fulfill the need? No. Again we have to go back to the process P0. What is the process P0? Process P0 has a need, status false. Yes. Whether its need is less than work? Yes. We can allocate the resource, complete its execution, make it true. Process P1 is true, process P0 is true. We done with the process P0, we done with the process P1. Now again we will take out the next I. Process P0 is completed, take the process P1. Condition fail. Why? It's already true. So take the next process P2. Now process P2 is false. Yes. Its need is less than work. Now its need is less than what? Allocate it, use it, release it, make it available into the pool. Now again go back to the process P0. Its status is true or false? True. Process P0? True. All processes are true. So what does it mean? It's into the safe state. Have you got?